Number 1, an automobile company has two factories assembling its luxury cars. The company is interested in whether consumers rate cars produced at one factory more highly than cars produced at the other factory. Factory A assembles 60% of the cars. A recent study indicated that 70% of the cars made by this company, both factories combined, were highly rated. All right, so we've got 60% of the cars made by Factory A. We've got 70% of the cars of this company were both combined were highly rated. And the same survey indicated that 10% of all of its cars were made by B were not highly rated. So, how can we make a hypothetical 1,000 table from this? Well, we're going to assume that we have 1,000 cars. 60% of them were made at Factory A. So 60% is 0.6 out of 1,000 of them. 60% of 1,000 is 600. So 600 of those cars were made at Factory A, which means 400 were made at Factory B. 70% of the cars overall between both of them were highly rated. So 700 were highly rated, which clearly means 300 were not. 10% of cars that were made at both Factory B that were made at Factory B were not highly rated. So Factory B not highly rated is 10%, which is 100. So we can now finish filling in the two-way table. There has to be 200 from there, 400 from there, and 300 checks both ways there. So now that we have our two-way table, we can work with this. A luxury car is randomly selected, so I'm randomly selecting a car from my 1000. What's the probability that it's highly rated? Well, highly rated, 700 out of 1,000, which is 70%, or 0.7. A randomly selected car is assembled in Factory B, so we know it's from Factory B. So my universe has now shrunk down to Factory B, so I'm only picking from those 400 cars. What's the probability this car is highly rated? Well, 300 of those were highly rated. So this is 3/4, 0.75, or 75%. Versus a randomly selected car was highly rated. So I now know that this car was highly rated, so my universe has shrunk down to those 700 cars. What's the probability that it's from B? What's the probability that it's from B? Well, of those 700 cars, I'm trapped in this column here. 300 of them were from Factory B. So that's 3/7. As a decimal, what is 3/7? 3/7 is 0.428, 0.429. So it's about 0.429, which is about 42.9%. Make sure you understand how these two probabilities are different. In the first one, I knew it was from Factory B. I wanted to know what's the probability that it's highly rated. So my universe shrunk to Factory B. I know it's from Factory B. I'm only picking cars from there. Versus my universe shrunk to highly rated cars, so I'm only picking from cars that are highly rated now. What's the probability I pull one from Factory B? It's important that we understand the difference between those two probabilities. The Waldo School Board asks eligible voters to evaluate their town's library service. Data based on gender and rating of the library are partially shown in the two-way table below. So two-way tables are like puzzles. We have to figure out what are the missing pieces of this puzzle here. So we need to find boxes that we can currently fill in. And the first one that came to my attention was the male and good box. That box in the upper corner here. Because 184 total, 93 are female, so if I subtract those, I get 91 males. I can also fill out this box over here. 515 total, 274 are female. 515 minus 274. 515 minus 274 gives me 241 males. Well, that now lets me fill in this poor because I have the whole row but one. There's 241 total. 41 did not use, 64 said average, 91 said good, which leaves me with 42 for poor. If I subtract those all the way from 241, I can add those together to get this total, which gives me 97. Can finish filling in this row here. There's 515 total. I use 97 for did not use 97 for poor, and 184 for good, which leaves me with 137 for average. That's the total for average. 137 minus 64 gives me 73. Hopefully I can fill in this last box in two different ways. 97 minus 44 is 53. Let's check that that row checks out. 53 plus 55 plus 73 plus 93 gives me 274. So my two-way table works all the way around. So for each of the following probabilities, write your answer as a fraction and a decimal to 3 decimal places, so to the nearest thousandth. What is the probability a randomly selected person who completed the survey is male? So I'm picking anyone who did the survey, and I want to pick them to be male. There's 241. So that's it as a fraction. I now need to get a decimal approximation for that. So type that into your calculator, and you get 0.4679, so I'm going to round that up to 0.468. Notice that I didn't make it a percent because it said as a decimal to 3 decimal places. What's the probability a randomly selected person who completed a survey rated the library as good? So I want to know what's the probability of good. I'm picking a random person. There's 515 of them. Good was 184. 184 people said good. So 184 out of 515 gives me 0.357. What's the probability a randomly selected person who completed the survey rated the services as good and male? So I need them to be good and male, which leaves me with 91. I'm picking that person at random, so it's out of the total. What's that as a decimal? 91 out of 515 gives me 0.177 if I round, about 17.7%. Finally, a randomly selected person who completed the survey rated the library services as good. So I know they picked good. So my universe now is shrinking down to the good row, the good column, not row, column. So I know they picked good. My universe has shrunk from 515 to only these 184. What's the probability this person is male? What's the probability this person is male? Well, that's 91 people out of, well, I only have 184 because I know information about this person. They picked good. So what's that probability? 91 out of 184 is approximately 0.495 when rounded. Hopefully you feel comfortable working with two-way tables because we're going to spend the next 2 lessons working with them, and we need to get comfortable computing probabilities working with two-way tables.